Right, question 2, part A, says show that f of x equals sine to the minus 1 of x minus 2x to the power 3 over 2 plus 1 has a stationary value when x satisfies this. Okay, so we have a little bit of extra work here to do at the start. Alright, it's talking about stationary values. So of course, if you remember, stationary values is where we have a maximum or a minimum. Yeah, so it could be a maximum or a minimum, and of course at a maximum or a minimum, of course you've got dy dx equals to 0, if you remember that. Yeah, dy dx equals to 0 as a stationary point. Now of course, different terminology here. If they give the function in terms of f of x, then we would say f dash of x, okay, for dy dx. So in addition to dy dx equals 0, we could also say f dash of x equals 0, which is what we're going to use in this case here. Okay, so let's work out this here then, part A. If we have f of x equals sine to the minus 1x minus 2x to the power 3 over 2 plus 1, right? When you do f dash of x, okay, you need to differentiate this here. Now this result is in the formula booklet, okay, so you can go to the formula booklet. I can't remember what page it's on the one with derivatives and so on, but it's on there, and you get sine to minus 1 of x is just 1 over 1 square root of 1 minus x squared. Okay, now when you differentiate this here, then you bring the 3 over 2 down, okay, and you times it by the 2, so that would become 3, okay, and then x, and you take a power away from that, that'll become x to the power half, right? And then the plus 1 just disappears, of course. Now at stationary points, okay, we could say at stationary points, of course, as we've just discussed, f dash of x equals 0, okay, f dash of x equals 0, so that means this is equal to 0, okay, and in this case then, perhaps one thing you'll notice here, which will help us, is that that's a square root, x to the power half a square root of x. What perhaps I'll do is I'll take that over the other side, and I'll rewrite it as root x, okay. Now perhaps what we can do next is just square the whole thing, right? When you look at the result we want, okay, let's just square everything, okay, so square all sides, okay. So if we square all sides, we need to square this, and we need to square this, okay. So if we're squaring this here, we end up having 1 on the top. Okay, so obviously when you square this side, you've got to square the whole side, so we put a bracket there. So you square the top, you get 1, square the bottom. If you square square root, it just sort of cancels it out. So you get that. If we square this side, okay, you end up having 9x. You think about it, because you square 3, you get 9. Square the square root, you just back to x. Alright? So 9x. The next what I would do is, I would take that 1 minus x squared over the other side and multiply, okay, because you're dividing by 1 minus x squared, take it over and multiply the whole side by 1 minus x squared, and then you have 1 equals, now expand this bracket, 9x minus 9x cubed, take everything over to the left hand side, okay, and you have the result, or actually plus 1, shouldn't it? If you take all that over, you have the result that they wanted, okay. Excellent. So, part B, it says, part B, show that the equation 9x cubed minus 9x plus 1 equals 0 has a root alpha between 0 and 0.2. So what we can do now is actually find a solution, okay? We'll find a solution to this, okay? The stationary values, we can find a solution here. They want us to show there's a root between 0 and 0.2. Now what I would do is I would call this f of x again, right? I know it's a different f of x, but call it f of x and equals 9x cubed minus 9x plus 1, okay? So even though it's equal to 0, call it a function, right? Call it f of x, alright? And then show that it's got a root alpha between 0 and 0.2. So all we have to do is plug 0 in, okay? So 9 times 0 cubed minus 9 times 0 plus 1. Well, I can do that quickly. That becomes 1. And if you plug 1 in, oh no, not 1, sorry. If you plug 0.2 in, plus 1. Okay, so put that in. So we have okay, that comes out to be a negative. Now what I hope you notice there is that there is a change in sign. Okay, f of 0 gives a positive, f of 0.2 gives a negative. So we say change in sign. Therefore, root alpha lies between 0 and 0.2. Okay, then it says the recurrence relation here, where x naught equals 0.1 can be used for alpha. Find and record values for x1, x2, x3. So if I put x naught to equal 0.1, okay, then I can get x1 then by putting it into that relation formula. Okay, so remember now on your calculator, put 0.1 and press equals. Okay, now that becomes your answer. So if we set that formula up, as we've got it there, okay, so we'll have ants cubed plus 1/9. Okay, so if you do that, as we did before, so we get the next answer. So press the SD button. So write it all down, 0.1121111 and so on, right? Press equals again, it'll give you the next answer. Okay, so x2 is 0.1125202246. Press it again then to get x3. x3 will equal 0.1125357073. Okay, so it does say then write the value of x3 correct to 5 decimal places. So x3 will be 0.11254, of course. Okay, sorry, I'm off the screen there. Okay, so if you look at that there for x3, when you round that then to 4 decimal places, 5 decimal places, you get that answer. Okay, now it says prove that this is the value of alpha correct to 5 decimal places. So prove that this is correct. Okay, so what we do is quite simply we draw a number line. Okay, right now we want to prove that this is the correct value to 5 decimal places. So the next one to 5 decimal places, of course, would have been 0.11255, and the one before would be 0.11253. What you do then is you check the ones in the middle. Okay. Okay, so in between 0.11253 and 54, it would be 0.112535, and there between the 54 and 55 would be 0.112545. Okay, so you're going to check these two values, and hopefully, if there is a change in sign, we know the result, because there's a change in sign, maybe that's negative, that's positive, for instance, then we know the result is in here somewhere, and we can say that that's the answer correct to 5 decimal places. Now what you need to do is put these values into your f of x here, okay? You've got to put it in there, the first one here. And don't put it into the iteration formula, don't put it into that, you've got to put it into this. So we have f of 0.112535, okay, so I'm putting it into that. Okay, that formula that we have earlier on. Okay, so if I work that out, okay, so that's cubed minus 9 plus 1. So if I work that out, there you can see I've got my answer in standard form, but it's positive, right? Because there's no negative there. So it's 1.14 times 10 to the power minus 5. Standard form, negative power means it's a really, really small number, but it's positive. If I try then the next one, 0.14545, of course you need to write what you're writing in your calculator. Okay. Okay, so what I'll do now, just to save myself time in the exam, of course, I'll just change these here. Okay, to 4.5, and I'll make sure to change the other one as well. Okay, and there you can see, look, I got a negative answer this time. Again, standard 4 minus 7.52, that will do, times 10 to the minus 5. But you can see there's a change in sign. Therefore, okay, answer is 0.11254 is correct to 5 decimal places. Okay.